Welcome to the online tutorial series of distributed DBMS. In this video, I will explain concurrency control algorithm with context of transaction management. I am Jishan Sheikh, Assistant Professor in IT/ICT Department of LJ Institute of Engineering and Technology. So, basically concurrency algorithm is divided into two parts, pessimistic algorithm and optimistic algorithm. Pessimistic algorithm is working on the principle of that if any transaction is accessing multiple database simultaneously and that data are shared, and if any problem is occur before that, how can we prevent that? If we are talking about optimistic algorithm is first provide the definition of particular data item. If any concurrency problem is occurring, then after it will find the solution. So pessimistic and optimistic algorithms are divided into number of algorithms. This is the list of pessimistic algorithm. Pessimistic algorithm is broadly divided into two categories, that is locking based and timestamp based. So two-phase locking based protocol is our first type, and second one is timestamp ordering algorithms. Two-phase locking algorithm is divided into the another categories, that is based on how particular data items are maintained by the log manager or scheduler. So it might be centralized, distributed, majority, bias. And timestamp base is divided into the three parts: basic, timestamp on ordering base, multi-version, and conservation. So let's start first our two-phase locking base protocol. So when we are talking about two-phase locking protocol, then we have to consider the scenario of how the particular data item is reading those data. So when any transaction is requesting for the shared data, and who takes care about that? So that is all about the log manager or scheduler. So here transactions indicates either interaction or how the particular data requests are generated by any specific transaction. If any transaction is requesting for data, that data item is shared or not shared, that might be two possibilities. If our data item is used by read and we are putting log, that can be considered as a read log. That is also known as a shared log. And if data item is shared and if any transaction is requesting for write operation and scheduler is putting one log, that is known as a write log, and it is known as a exclusive log. If any data item is already logged by our scheduler and another transaction is requesting for the same data, then what happens? So according to that, if the data item is available or not, if it is compatible or not, for that we have to understand this particular scenario. If data item X is available here, that data item is used by particular transaction T1 and that transaction is used X for reading those data. And T2 transaction is requesting for the same data item X. So that time particular scheduler can give that data item to transaction T2, because we already see that read log is also known as a shared log. So multiple transaction can use that shared data item which is available under the read log. So that's why read log is considered here yes. So here compatibility is achieved here. If the same data item X is used by T1 and that is done by particular transaction and it is used for the purpose of write operation, and transaction T2 is requesting for the same data item which is used by T1 for the purpose of writing of data, but that time we cannot give this data for reading purpose because already T1 is writing the data. So in future it might be data value will be changed, and the same time if T2 is reading the data, then compatibility cannot be achieved. So that's why if any transaction is reading the data, that is in the read log, and any other transaction is requesting for the data for writing operation, then it is incompatible. That's why we are putting here no. The same way we can consider for our write operation. If transaction T1 is already hold the writing operation and any other transaction read is requesting for read operation, the same context will be used here and the compatibility is not matched, and we can say that it is non-compatible format. So we can say that it is a no considered. The same way, if some data item is used exclusive log and another transaction is requesting for the same purpose, for writing purpose, we can say that it is incompatible. So in the future algorithm, we have to use this compatibility. So make sure it will clear in your mind. So let's consider the particular scenario how the log-based transaction is used. So for that we have to consider two phases, growing phase and shrinking phase. If any data items are used by our transaction, for that first it requests to the transaction manager. Transaction manager will check the same data item is available, it is used by any other transaction or not. If that transaction manager found that that data item is not used by any other transaction, then it will give to this particular requested transaction. If that data item is sent by this particular log manager to requested transaction, then first it puts on lock. So that locking process is all about the obtain the lock. So when the particular transaction is requesting the data, it will achieve that particular data item using the concept of lock. Then is find the process of obtaining lock. So if the same transaction is requesting for another data, the same procedure will be performed by the scheduler or lock manager, and then it receive the data. So what happened here? If same transaction is acquiring the lock to the multiple data item, then another transaction will have to wait till now what that already locked is achieved by that particular transaction is released. So two phases are there here, growing and shrinking phase. In the growing phase, lock is obtained by this particular lock manager. In the shrinking phase, that is the second part, it will be you can see in the figure that is denoted by the below arrow here. So that is the releasing the lock after completion of that particular task. That particular transaction will release that lock item. Now, what happened here if the same transaction is achieving multiple data item locks here? That's why here what happened, we are using the concept of strict two-phase locking protocol. So here in strict two-phase locking protocol, particular transaction is achieving the lock, hold the lock until the end. After the completion of this particular task, it will release that. This is what we are facing the disadvantage in our normal two-phase locking concept, that will be removed by here our strict two-phase locking protocol. Now we are moving to our first protocol, that is all about centralized or primary two-phase locking protocol. So here in centralized primary two-phase locking protocol, only one scheduler is available in distributed system. So there are multiple sites are there, but locking requests are taken care by only one site here. So that site is known as a centralized site. If any transaction is requesting for data item, first it will check where the particular centralized server is available. That server is maintaining all the process of scheduling. So log requests are issued at the centralized scheduler database. If any request is coming for that particular transaction, it will consider into the three parts here. First part will be your coordinator transaction management, that will be generated by the transaction side. Next one is centralized log manager, that is maintaining the scheduling task, and data processing at the particular participating sites. So when the participating site is requesting for some data item, it is requested for a particular site. That site is known as a control site. So control site is nothing but where the user request is coming. That site is known as a control site. If control site having the control of scheduling algorithm, then it will generate that. But if the scheduling algorithm or scheduler is not properly maintained there, then it will forward that request to the particular site where the scheduler is properly maintained. So when the data item is requested by this particular transaction manager, then log request will be forward to the particular centralized site where the log manager is obtaining this particular data item logs. In the response, if particular data item is not held by any other particular transaction, then particular data item is available to that transaction. For that, lock is granted. So first two steps of this algorithm is all about lock request, that is done by coordinating transaction manager, and lock granted, that will be performed by central site to this particular coordinating transaction manager. Then after that lock, after the granting the lock, that particular site is processing the data for which it is requested. When the work of that particular shared data item is completed, then after the end of the operation, it will release the lock. So that release of the lock will be generated by coordinator transaction manager to centralized site lock manager. So this is the basic idea how the client server is working. The same way here, centralized, or we can say that primary site 2PL is working. But disadvantage is there, if centralized site lock manager is failure, then whole process will be on the downside. For that, we are not using in real-time scenario centralized two-phase locking protocol. So to remove the disadvantage of centralized two-phase, we are using the next, that is all about the primary copy two-phase locking protocol. So here what we are performing in primary copy 2PL, lock managers are implemented at the different sites. Not only single site is managing all these things. Multiple copies are generated and that copies are available at the different site. That means the concept of replica here. So replica of your lock manager scheduling is available at the different sites. The advantage of this particular algorithm is that at the particular single time, if any site is failure, another replica is available at the different site. So whole site is not at the downside. Now understand how primary copy 2PL is working here. So first, when the user request is coming from the particular centralized transaction manager to our particular site, then particular transaction manager is checking the available data item is locked by any other transaction or not. But before that, the transaction manager is decide which is primary copy and which is slave copy. So when the data item is requested by particular transaction manager, it will forward to this particular primary copies manager. If primary copy manager is available at the control side, it will generate the response. But if it is not available control side, it will forward to the next side. So primary copy is responsible for granting the lock and give the response to the user. After giving this particular response, any updation is generated by this particular primary copy server, then that particular update is released to the all that sites that are considered as a slave site here. So task of primary copy 2PL is here. When the user is requesting for that data item lock will be checked by only primary copy site. If data item is available, then it will give the response. If data item is not available, then it will reject the request. But when is requesting data item is approved by this primary copy 2PL server, then this update will be reflected to all the slaves copies. So if it is not possible concurrently, synchronously, then our concurrency cannot be achieved. So this is the basic idea how the primary copy 2PL is working. It removes the total disadvantages of our first algorithm, that is all about centralized copy 2PL. Now we are moving to the third algorithm, that is all about distributed two-phase locking protocol. So when we are talking about distributed two-phase locking protocol, the schedulers are placed at the each and every site. In the previous algorithm, primary copy 2PL, we are not considering that each and every site having the copy of our particular scheduler. But here, what happened here? Our particular scheduler can be implemented at the different sites. In primary copy is available. In distributed, scheduler is divided in the terms of our algorithm. So here, each and every scheduler handle the lock request for data item which is requested by the transaction manager. A transaction may read any of the replica copies of data item of HCL. That is the disadvantage of our primary copy 2PL. If any data item is requested by this particular site, it will check it can be obtained or not. If that is not availability, then it is redirected to the another site. But user cannot aware about that. This is all about the transparency of our DBPMS. So now understand how exactly this algorithm is working. Now we are talking about distributed copy 2PL, then it converted into the three parts: coordinating transaction manager, participating lock managers, and participating distributed processing. So when any request is generated by coordinating transaction manager, it is first requested to the participating lock manager. That log manager is performing the data item, what for that data item is requesting for that data. If log request is generated, then it's check what the operation want to perform. For the same, if the data item's answer is generated here, it end the operation and telling that my work is updated here. So after the ending the operation, it will check any requested data item is requested more data item or not. If data item is not requested for any write or read operation, it will release the log. So this is the last step of this particular algorithm. So this is the all about distributed 2PL, how these are working. So thank you for watching this video. In next video, I will cover remaining pessimistic and optimistic concurrency algorithm.